Welcome back. Today we're going to learn about speed. An object takes time to cover a particular distance is speed. What is velocity? Speed in a given direction is velocity. Velocity changes produces acceleration and changes of velocity produces acceleration. Distance, total length covered by an object. Displacement, total length covered by an object with a direction. Let us learn all these terms in this video. First we'll learn what is speed. Speed, it is the rate of change of distance or the distance travelled in unit time. Speed does not have direction. It has only magnitude. Hence, it is scalar quantity, or the speed carries with any direction, it would be positive. How to calculate speed? In SI unit of speed is meter second minus 1. To find speed, speed is equal to distance divided by time. This is how we have to find speed. How to calculate average speed? An object travels 16 meters in 4 seconds and then another 16 meters in 2 seconds. Calculate the average speed. Average speed is calculated by total distance divided by total time taken. Just notice the time given here with different time, 16 meters in 4 seconds and 16 meters in 2 seconds. Right, 16 meters plus 16 meters is 32 meters, and that should be divided by total time taken, that is 4 seconds and 2 seconds. Add this 4 and 2. You will get 6 seconds. Divide 32 meters divided by 6. You will get 5.33 meters second minus 1. So when 32 meters is divided by 6 seconds and the unit is meter and second, so the value of average speed is 5.33 meters second minus 1. Now let us learn what is distance. The actual length of the path travelled by a moving body irrespective of the direction. It is a scalar quantity. Distance is equal to speed into time. So the actual length of the path travelled by a moving body irrespective of the direction is distance. Now let us learn about displacement. The change in position of a moving body in a particular direction. As direction involves, it is a vector quantity. What is velocity? Velocity is the rate of change of displacement. So, when the displacement occurs, the velocity will be changed. It is the displacement in unit time. Velocity has both magnitude and direction. Hence, it is vector quantity, which is measured in meters second to the power of minus 1 in SI system. Velocity has positive and negative values. It can get both positive negative values. Positive will be in one direction. In the opposite direction, the velocity will be in negative values. So, velocity can also get zero value. How to calculate velocity? Velocity is equal to displacement divided by time taken. As we know, velocity implies with both displacement and time taken. Now let us learn acceleration. Acceleration having a close association with velocity. It is the rate of change of velocity with respect to time or in unit time. So when the velocity changes, it produces acceleration. As it involves with direction, it is a vector quantity, and the SI system unit is meter second minus 2. How to calculate acceleration? As it involves with change in velocity, acceleration will be calculated by change in velocity and divided by time taken. The change in velocity here, which has final and initial velocity. So final velocity has to be subtracted from initial velocity, and that should be divided by time t. So v minus u divided by time gives you acceleration. So A is equal to v minus u divided by time is your acceleration. And we have positive acceleration and negative acceleration in the condition of v is greater than u. V is final velocity, u is initial velocity, and v is less than u. You will get negative acceleration. What is negative acceleration? So the velocity ultimately decreases here, but the value of acceleration is also negative. Velocity decreases with the value of acceleration is negative. That is called negative acceleration, or otherwise it is called retardation or deceleration. Uniform acceleration. When an object changes its velocity with equal intervals of time is called uniform acceleration. Remember here the time interval is equal. Example, the motion of a ball rolling down. This is uniform acceleration. The object changes its velocity with equal interval, but this is opposite to non-uniform acceleration, where the object changes its velocity with unequal intervals of time. Example, a car travels in 2 km in the first hour, and in the second hour travels 3 km and 3.5 km in the third hour. Here the time is varying with time different distance coverage. Uniform circular motion or accelerated motion, here it implies with the object having a circular path. Example, Earth moves around the Sun and Moon moves around the Earth. Have you noticed here the planet Earth taking a circular path? So when an object moves along a circular path with constant speed is called uniform circular motion. Here, the change in velocity is due to the change in direction, hence we say it is accelerated motion. What is centripetal acceleration? When a body moves in a circular pattern, the acceleration is radially towards the center of the circle. So here, the acceleration only radially towards the center of the circle. That is called centripetal acceleration. That is A is equal to v square divided by r. Here v square is velocity, r is radius as it related to the circle. Centripetal force. What causes the centripetal acceleration? The force causing the centripetal acceleration, isn't it? So that directed towards the center of the circle. So that makes the centripetal acceleration directed towards the center of the circle. Now let us learn how to calculate magnitude of centripetal force. That is, F is equal to mass and centripetal acceleration. So mass is multiplied with centripetal acceleration, that is mv square divided by r. Now let us learn about centrifugal force. Force acting on a body away from the center of a circular path. So they don't have centers, it's just away from the circular path. It is called centrifugal force. The magnitude here is same as that of centripetal force. Here CF refers centripetal force. Magnitude is same as that of centripetal force. Let us learn some formula here. That is V square is equal to U square plus AS. So what is all this V square, U square and AS? It is a relation between initial final velocity, acceleration and displacement in a uniformly accelerated straight line motion. In the second relationship, V is equal to U plus AT. This is relation between initial final velocity, acceleration and time in a uniformly accelerated straight line motion. And the third condition is S is equal to ut plus 1 by 2 at square. This is relation between initial velocity, acceleration, displacement and time.